Welcome to my vlog on big data and cybersecurity. My name is Lipyeow-Lim. I'm a computer scientist, an educator, and a software engineer. Today, I'm very excited to talk about IOC matching or IOC search using DiscoverX. DiscoverX is a library created by a friend and colleague, Ernie, and he recently released it about end of June to the public. And so this is available on DatabricksLabs. I'll just flash the repo real quick. This is the repo on GitHub. So definitely check it out. But you don't even need the repo because you can actually install it right using pip, right? But what's the deal with DiscoverX, right? DiscoverX will actually let you do schema-agnostic IOC search without needing to know the table schemas in your data, in your Lakehouse. What does that mean? It means that you can do IOC search without potentially normalizing any of your log data to a common data model. You can do IOC search without actually using any kind of a full text indexing technology. So that's pretty cool. So let's actually dive right in so you know what's going on, right? So first couple of commands, just getting DiscoverX installed and set up. We run some configuration, create a catalog database. We're going to use the Zeek data set from some of my previous videos. We're going to load the Zeek data set into a bunch of tables, and you see the usual suspect, a connection table, DHCP, DNS, HTTP, and so on and so forth, right? Once this data is loaded, I'm actually going to pick an IP address and a FQDN to use as my test subjects, if you will, my test IOC search. So I print out all the IP addresses and their hit rates, and this is just for the DNS table, of course. And I'm just going to pick this one, right, for the IP address. And then for the FQDN, I again look at the DNS data set, and I'm going to pick this one because it's hard. There's about four occurrences of these in the DNS data set. There might be more in the other data sets. But this one is hard from an FQDN point of view because it doesn't have any dots in them. Okay, so let's use DiscoverX now. So you first create a DiscoverX object, and then you use the scan method, and you specify what tables it should scan. In this case, it just gave it the default catalog name and the database name that I created with all those Zeek tables, and just use star to say scan all of those tables, right? I did specify a sample size. Again, DiscoverX will sample the data in each column and actually run some regexes on that sample to see what kind of data it is. And you see what I mean a little bit. So after you scan it, it will run Spark jobs. So actually scan that, and then it will, so it's scanning all these tables, and it will summarize the results saying, oh, I'm able to classify 48 out of 121 columns. And I found some decimal numbers. I found an email address column, 10 FQDN columns, 29 IPv4 columns, and so on and so forth, right? There's more details here in this table format, and even gives you the score, which is an estimate of the frequency of occurrences of these data types within that column based on the random sampling, right? I will point out that for the DNS query column, that FQDN matches only about 97%, right? Others are sort of 100%, like the source and destination addresses. Those were clearly all IP addresses in those columns. You can also look at the rule set that's given to you out of the box. These are the rule set that's given out of the box. For cybersecurity, we're obviously most interested in email addresses, FQDNs, IP addresses, MAC addresses. If you are working in sort of privacy or governance type applications, you may be interested in credit card numbers, social security numbers, and so on. And what does the scan result look like in a data frame? You can it's actually available to you in a data frame. So just do a display on dx.scan result, and you can see that the entire table is available to you as a data frame as well. Okay, now we've done the scan. Now we're ready to actually do the schema-agnostic IOC search. So it's extremely simple. DiscoverX provides you with a single method call called search, and I give it the IP address that I want to search. I tell it to search from the tables, and in this case, I just want to search through all the tables that's available to DiscoverX that we've sort of scanned earlier. And you actually go and fire off queries to each of these, each of the matching tables with columns, and actually run that search and bring back the results. In this case, it will actually auto-detect that this search term is an IP address and actually look for, only run the search against those tables with columns of IP address type. It brought back two results, two rows as results. And it gives you, where it came from, the catalog, the database name, and the table name. The search result, in this case, is from this column, and the value is this. And it gives you the row content as a JSON. So that's pretty cool. That's pretty much all I need, actually, from a security use case or analyst point of view. Now, let's try searching for an FQDN. Right? In this case, I plug in the FQDN that I chosen earlier. In this case, I'm going to help DiscoverX a little bit because, again, it's impossible to figure out that this is an FQDN. So I can specify by class FQDN to give it a hint that you should just restrict your search to tables with FQDN fields. And that's what it does. And it brought back 4 rows as the result. And the result looks pretty good. Those are the DNS records that we know about. Now you can also specify a minimum score on the classification confidence. So remember, I said that the DNS FQDN, the DNS query column, that it was classified to be an FQDN type with only 97%. So if I do a min score of 1, I should get 0 results, and that's indeed what I got. Now, the DX is a object that's, in this case, is stored in memory, and it's transient. Once I exit this notebook, it's gone. How do I use it later on? Well, DiscoverX actually gives you the save function. You can save the object. It's like serializing the object into a Delta Lake table. In this case, I call it IOC DX. And then you can actually recover that later on. And if you look at IOCDX, you see those metadata that DiscoverX discovered, right? Now let's actually load I created a new DX new DiscoverX instance, and I load the data from the IOCDX table to actually get back that DX new object. And I can actually do a sanity check. I did the DX new search, the search that I did earlier, and it does work as before. Now, what does this all mean? This means that in the absence of any full text search technology, a security analyst can perform IOC searches without knowing the table schemas in a notebook environment, right? From a cost and TCO perspective, this also means that IOC search using DiscoverX mitigates the need for ELT pipelines to normalize the log data into a common data model. And it mitigates the need for full text search indexing technology, right? The ELT pipelines do cost money, do cost compute and DBUs to run, and also any full text search indexing technology also costs DBUs and compute and money to actually index the data and actually to serve the queries out using the index. This is all not free. You're actually trading costs for search performance and interactive experience. I think, again, don't expect sub-seconds or millisecond type performance for these kinds of searches. It is searching across multiple tables. If the data size is big, it will take multiple seconds. So, but on the other hand, the kinds of cost savings you're going to get, this essentially allows you to do IOC search without knowing the schemas on a shoestring budget.